Now try out these two questions in the similar manner how we have done the previous ones. These are good level of questions, hence you may take little time to solve it. So take your own time, solve it very carefully, and then we will discuss the solution of these questions. So I hope you would have solved these questions. I'll be discussing the solution of these questions over here and we'll write the answer over here. So let's see what is the first question. So first question is where we have both the ends are symmetric. So it won't matter from where we are, where H plus is attacking, and removing the OH as water, forming the protonated alcohol. So what will happen? H plus will attack on either of them. So let's say it has attacked over here, will form a protonated alcohol. Now, removal of this water molecule will take place and this will get converted into its respective carbocation. Now, once we have got carbocation, we have already understood this, that this plus charge has to shift over here to get the plus M stability of OH. Now, out of pH and this molecule, which molecule will migrate on the other carbon? So I had explained to you in the previous example that the species which is going to reduce the magnitude of the plus charge should shift on the other carbon. So this is an electron donating group, okay, and hence will reduce the plus charge, or will reduce the magnitude of positive charge. Hence this should shift on this side and plus charge will shift on this carbon. Why this is shifting? Again, because this is an electron donating species and will reduce the magnitude of plus charge. Though magnitude will reduce a bit due to the resonance happening inside the benzene also, because that plus will get shifted in the benzene and it will get dispersed in the whole benzene ring. But still, magnitude is much lesser in case of this as compared to this. Hence this particular species will shift over the other carbon and benzene will stay there, forming COH plus PH C PH OCH3 and OCH3. Now the regular process will take place. Now what O will do, will form a bond over here, will kick out the hydrogen and we will get a ketone over here. So it will be benzene, C double bond O, C, benzene, OCH3 and benzene with OCH3. So what will be the product form? This will be the product form. I'll write it over here. The product is, I'll write it neatly over here. C double bond O, C, PH, OCH3 and then again benzene with OCH3. Is this clear? Now, let's see the solution for the next question. Now, what's happening in the next question? So, we have two unsymmetric places where O can get attached with H plus to form a protonated alcohol. Now we have to decide where H plus will go. So H plus will go in that on that OH where you can form a better stable carbocation. So if H plus will attack over here to form a protonated alcohol, the carbocation formed at this position will get stability due to the resonance by this benzene as well as this benzene, whereas the positive charge formed over here is a cyclopentyl carbocation, which is highly unstable carbocation. So rather than this OH getting attacked by H plus, this will get attached by H plus and will form the protonated alcohol like this. OH, COH2 plus, pH and pH. Now this protonated alcohol will get released. So this H2O will get released. So now when the water will get released, We already know what happens. The positive charge will form, a carbocation will form. So this carbocation will form. Once the carbocation is formed, we know what happens. It is the usual process. The plus charge will shift on the other carbon to get plus M stability of OH, and this one of the species will shift on this particular carbon. So here what will shift exactly? So basically, if plus charge shifts on this carbon, or if we want plus charge to shift on this carbon, we have to do the ring expansion. So ring expansion will take place. The bond between this carbon and this carbon will form. Let's number these carbons. This is first, second, third, fourth and fifth. So fifth carbon and this carbon, the new bond will form, whereas the bond between first carbon and fifth carbon will break, leading to the shifting of plus charge over here. Okay, it's not exactly shifting basically. So this bond is breaking, getting a negative charge over here, and this is getting a positive charge here. Negative and positive species are forming a bond, and this first carbon will retain its positive charge. So this will look like this. That's how the structure would be, with the plus charge here and OH. Okay, now again from this oxygen, the pair of electron will try to form a bond, kicking out this H and forming my bad, I have just tilted this. So that's how it will be, forming double bond O over here. Okay, and this can be rearranged to write it as, this is a 6-membered ring now, 1, 2, 3, 4, 5, 6, 6-membered ring now, double bond O. Now it will form a 6-membered ring with double bond O over here, and then pH and pH. So what will be the product form? Product is, this is the final product with the ring expansion. This is a very important question, has been asked before in an IIT advanced exam. So this is forming, I am writing the product of this over here. Again, this cyclohexane ring with the ketone and 2 benzene rings attached to it. This is my final product. Let's understand once again what has happened in the reaction. First of all, we had these two groups where the OH was present. If we remove OH from here and the carbocation will be formed, this will be much more stable carbocation. Hence, the protonated alcohol will be formed over here, and this H2O will get released to form a carbocation over here. Now, because the carbocation's plus charge has to shift close to OH so that it can get the plus M stability, this pentane ring will try to do the ring expansion to get the plus charge. So this will expand. The fifth carbon will try to form a bond with this sixth carbon, and the first carbon will gain a positive charge because the bond between first and fifth carbon will break, and this will get converted into this type of ring, which will again form this. So here we have got OH plus charge. This will form a ketone over here by loss of H plus ion. So by loss of H plus ion over here, and this will form a ketone which I can rearrange to form a cyclohexane with double bond O, pH and pH. I hope you must have. I hope you would have got all the questions what we have done of different types. Now you can get any type of questions from this part, and they generally give you the ones with the ring expansion, ring contraction, so that multiple concepts can be clubbed up together and can be asked in one single question in advance. So this is very important topic for advance. Whenever you are doing question, be a little more careful while solving it.